Thank you so much. Yeah, great to be here. Hello, everyone. I actually thought about it today. I travel quite a lot and speak at different stages around the globe, but it's my first time at DappCon this year in my hometown Berlin, so it's very great to be here and to share some of my knowledge or the knowledge that we develop and have acquired at Phala Network about off-chain computation. I'm Zoe. I'm VP of Growth and Partner at Phala Network, and we provide a decentralized off-chain computation infrastructure. The title is Problems, Reality, and a Trustless Solution. I won't go too deep into all the problems, but of course there are some things that we can improve in Web3, specifically when we talk about computation for dApps, backend services, as well as when it comes to off-chain computation. And as we all know, smart contracts are a very important component in our Web3 tech stack. But we at Phala have the thesis that smart contracts are not really smart without connectivity. And connectivity in terms of actually reading information from the off-chain world and the on-chain world. But on-chain, or what is actually off-chain, we define it in different terms, because if you look at different chains like Polygon from Ethereum to Polygon, would Polygon also an off-chain network, right? It would be off-chain. From Polygon to Arbitrum, it's also an off-chain connection. However, all of these platforms are trustless platforms or protocols. So the question is, or what we are trying to solve and look into, is how we can actually connect these trustless platforms in an off-chain or with an off-chain solution. And to explore this a bit further, I don't know if you guys have heard about the FET protocol. Yeah, some of you, cool. We actually got very inspired by the name and the protocol. You will find out later why. And I would like to deep a bit into this. It's a nice visualization that shows the initial web, we call it Web 2, right? Where the value captured or also created is mainly on the application layer. We have fat applications or rich applications and a very thin protocol layer. Now in Web 3, when we started to implement blockchain in the overall internet tech stack, we actually turned the page, right? And we have now value captured or value creation on the protocol layer. But with this is coming also that we have quite thin applications. So we have a fat protocol and thin applications. We now said, okay, or if we go deeper into the application layer in Web3, where we have fat protocols but thin applications, what about the smart contracts that are an important component of these applications? And if you look into most of the dApps, most of you guys are builders, I guess, they're also developers, you develop your own dApps. We actually have very thin contracts at the moment, but a very fat or rich backend. And fat in this case, that most of the backends are still hosted in a centralized way. So we have a lot of computation, storage, right, on these centralized or provided by centralized backend providers, and then a very thin contract that runs on chain. Which is also okay, because we don't want to make the blockchain also too fat. So, but how would it be if we actually have fat contracts? So a dApp could be actually more rich, or actually better, could create more use cases if we provide fat contracts at a thin backend. So we at Phala say, okay, to create this, we need to upgrade these smart contracts and create smart contracts with verifiable computation. So we can actually lean or make this backend small or thinner and have the fat contract that actually dedicates or communicates with the dApps more rich. So we say, okay, we need two things to actually create this verifiable computation or make these smart contracts thicker or fat. The one thing is add connectivity. At the moment, smart contracts don't really, or they lack a little bit of connectivity. They cannot communicate with the internet. How about adding connectivity? So your smart contract can send HTTPS requests, and you can talk to any Web 2 API or any internet protocol in the Web 2 world. And the second part that we also need is the verifiable computation. Computation is super important, but as we just learned, it's mainly provided by centralized services. And we can verify we can verify the computation in an off-chain world, but send this information or save this proof on the chain. And this is what we have developed at Phala Network, and we call it Fed contract. That's where the inspiration comes from the Fed protocol. So it's we actually adjusted it with the PH, so it fits into our branding with Phala. This is a contract. We call it an off-chain programming model that is run on our own infrastructure, on our own decentralized computation infrastructure. And Fed contract because it's a contract that's richer than a smart contract. We also like to say it can actually make smart contracts even smarter. So what can this Fed contract actually do or provide, especially for US dApp builders? The killer feature, so to say, is the internet connectivity. This contract is mainly runs in our off-chain network, and we actually have interesting architecture. I will show it in a minute, where we can provide secure verification, not direct on our chain, but in a separate layer. Based on this, because we provide most of this commutation of this contract in an off-chain environment, we can easily communicate with Web2 APIs or internet protocols via HTTPS requests. Omni-chain connectivity, very important, right? We want to communicate with several chains or have this contract actually not deciding if it's based on EVM or maybe also communicates with the substrate chain or similar. So we can easily use our internet connectivity to directly launch or connect to any RPC node on any chain. Functions feature is very nice because this contract actually on a very low level is written in Rust. However, we are EVM compatible, but not too many developers like this language, so we said, okay, we abstract all of this, and you can actually modify or customize Fed contract in JavaScript. And the fourth benefit is the verifiable computation. So based on the architecture, we can verify any information in the contract before we actually send this on-chain. What can we do with Fed contract? We are working very closely with the Web3 social environment, specifically with Lens. Who's using Lens? Lensstar? Cool, very good. Very cool protocol and a cool team also. We have developed a use case called Web3 social, actually the Lens API Oracle. Lens has an API, also an SDK, so you know. This API, however, is not decentralized, the Web2 API. And the dApp developers that want to communicate or send this information into their Polygon smart contracts can't do this. They do their own hand-rolled up oracles or whatever. So we created the Lens API Oracle, which runs on our contract. And here's just an example what this oracle or this solution can do. It's more like an intent or a connection. If you say, if you have followed this profile, then we can actually verify or see that you get rewarded in Matic. If you have mirrored a specific post, then you can be whitelisted. So it's an if-then connection that we can verify in the contract before you actually execute it in the Polygon smart contract. Yeah, I didn't want to do a live demo, so I just put some screenshots here from our of the UI. What I want to show with this is that we put a lot of effort, thoughts, and love, if you want to say so, into the UI and the developer experience. This is actually how you use the Lens API Oracle, almost no-code, or if you want to say low-code UI. We have here the infrastructure, just for this use case. You can pick the profile that you want to work with. On the left-hand side, you have the API data from the Lens API, and you can customize it in the JSON paths below as well. Then you can review everything, and then actually you directly deploy this kind of oracle. We use a stake-to-compute model because we have the computation in the backend. You, at the moment, still need a bit of our own native token, which is far, and you stake this to actually execute this contract. But whenever you decide to not use the service anymore, you can unstake, and you have actually kind of free compute. So in summary, we want to, or with this use case, we actually motivate or incentivize developers in the Lens ecosystem to deploy their own oracle in almost 5 minutes. They pick what they need, they customize it, and they deploy it. Fed contract is this contract that executes everything what I just explained in the back end. And the Lens API Oracle, what I what is this use case is a specific blueprint. So we wanted to abstract it a bit and say, okay, we are building blueprints or want to inspire developers to build their own blueprints with it. And another use case or another blueprint that we have built is Fed contract plus AI. We just heard the nice speech also about the combination. And we built a Web3 AI agent, actually at East Global in Paris. More the engineering team than myself. But it was a very cool experience because we wanted to showcase how Fed contract can combine, or how we can combine the off-chain computation with the AI part. This is our product we developed there. It's called Smart Cookie. And it's actually a browser extension that helps you or refers you, provides you information based on your activity in your web browser, but focused on Web3 applications. This is actually how it works. So it's a Chrome extension. It runs on Fed contract, and what it does, it recommends you specific activities. If we go back, for example, you like or you buy an NFT collection on OpenSea, then you open maybe Lenster, and then you get the recommendation to follow the specific artist that you just bought the NFT collection from. Or you own a specific token, and then you also open your application on Lens, and then you say, hey, do you want to follow this person, this leader? It's actually his company that you just bought tokens from. Yeah, and here just, again, that you see we integrated also the different tech stacks, AirStack for the API request lens, and communicate there through HTTPS requests. That comes from Fed contract, and Fed contract runs on our own blockchain network. Yeah, actually the first announcement, or I'm announcing it the first, we are launching in 2 weeks soon, Fed contract 2.0, which is just a little upgrade in terms of like adding more features to the overall key features of Fed contract itself. The main feature that we are adding is actually kind of like a functionality, meaning that we expanded the contract that you are able to call any Web2 API and push it directly in any kind of smart contract. With the Lens API Oracle, we were focused on the Lens API. Now we actually broaden up, and with the launch, I think we have around 5 APIs already that developers can choose and select, and there will be added more, so you can directly pick and choose the API, configure what you want to read from the API, and we push it through our Fed contract into your smart contract. Yeah, so this is the most important part, actually. So it's nice and cool to hear about Fed contract, but how does it work in the back end? Why can we actually provide this verifiable computation? This is our pretty innovative, I like to say, infrastructure. We have L1, which is our own blockchain. And the cool part is that we separate the consensus on the blockchain from the actual computation. So consensus is separated from the computation part. The computation is represented by the black layer, and this is the part where most of the contract also runs, but it's hosted or secured by secure workers. So everything that's executed in this layer can be verified, and then we just push the proof on chain. The fact that we have this computation part off chain, we can easily connect to any EVM substrate chain or whatever. So this is actually the magic, how we can offer this Fed contract that communicates off-chain in a secure way. Yeah, and if you haven't heard about Fala Network before, now you actually know what we are doing. To put this into perspective, we are actually the biggest Web3 cloud, completely decentralized. We have almost 200,000 virtual CPU up and running. We don't own any of these nodes or servers. This is all community run. We have a pretty attractive tokenomics to incentivize all the node providers to provide their CPU. These CPUs, they are secured by the online workers, and then some more numbers on cross-chain transactions and on-chain accounts. And that's it from my side. Yeah, happy to answer some questions. Thank you so much.
Thank you very much, Zoe, for that wonderful talk. So if anyone has any questions, feel free to raise your hands. Yes, you, sir.
Hi. Thanks for the talk. Could you elaborate a little bit on the verifiable part, on what exactly do you mean by verifiable computation and what techniques do you use? Is it like trusted computing modules like SGX or some cryptographic techniques, or what is it?
Yes, everything you said. No, so as you saw on the infrastructure part, the off-chain part is secure enclaves. It is based on SGX, on trusted execution environments. So every node operator needs to secure or needs to provide an SGX node, right? We cannot use any other technology or hardware. And we have implemented like a performance test that we can ensure that these nodes are also, that they perform good, and a slashing mechanism in case they are up or down to actually ensure that they also execute what they in a good way, right? That these are good nodes. Based on this, because it's based on SGX, we can actually verify. But if you only would host this off-chain, you don't have to prove, because no one can access an SGX hardware, which is the good thing. So that's why we have our L1 to send the proof to the chain, and then you can verify with the proof on chain.
Yes. Did you have your hand? Sorry. Oh, yes.
Just, I guess I'm assuming this kind of works in a completely open way since it's decentralized, so there's no privacy preservation, right? Are you guys trying to tackle that problem?
Privacy?
Yeah, as in like nobody can eavesdrop into the computation itself.
Yeah, actually, we actually just rebranded. Our old website actually said the privacy compute protocol. We provide this privacy, right, through the architecture. We just don't position it exactly like this, because we found out that the more interesting part for the Dapp developers is this automation contract, the Fed contract, with privacy included, right? They get it just add on, if this answers your question. Or what? So
you guys are working on it. What there is essentially, you can't protect essentially the data that you're computing.
yeah, I mean, if you look into the architecture, it's set up with the privacy focus, right? It's a privacy computation, actually, architecture. But we are not, because there are other architectures now with ZK coming up, right? And people discuss, okay, ZK or TE, like we don't promote it as this privacy, but it is set up and architectured with a privacy intent, if this, okay.
Anyone else with questions? Then I guess that wraps it up. So yeah, thank you again, Zoe Meckbach.
Thank you.
Give a big round of applause.